All right, number 51 here in 2.2, they're asking us to sketch the graph of a function with the given limits. So they've given us three pieces of info here, one of which is a two-sided limit as x approaches 1, and then we have two different one-sided limits as x approaches 3, one from the left and one from the right. I would say with a problem like this, guys, don't overthink it. That's usually where people run into trouble. For starters here, all right, let's focus on what's going on here. We've got a two-sided limit as x is approaching 1, and that limit value is 2. Now, there's a lot, there's a lot of things that we could do if we wanted to make this really interesting, but frankly, I don't. I want to make this as simple as possible. So what I've got right here, guys, is, let's take a look, a y value. Let me keep going with that up to 4. I'm going to need that in a minute. There you go. So as x is approaching 1 from both sides now is what that means right there. Our y value is approaching 2. There's nothing that says this can't be a continuous function there, so I'm just going to go ahead and use the ordered pair 1, 2, and put that right there. And I think then I can draw this thing continuous to that point there. Now, there's nothing else it says about what it could or could not be doing there, so I could draw a curve that, I don't know, just looks something like that. Okay, and there you go. Now, I'm going to draw the right half of this as well, but I do want to focus on what's happening here. Now, what I want to notice, is, or what you want you guys to notice, is that these two limits right here are one-sided limits as x is approaching 3, one from the left and one from the right. So stealing a little bit about what we're going to talk about later on here in section 2.4, we actually have a discontinuity here, guys. As x is approaching 3 from the left, our function is narrowing in on 0. So that means that we would have a point here at 3, 0. Now, whether it's open or closed, that's going to be up to you guys. Now, let me say where I'm going with that in a second. I also see on the second part that as x is approaching 3 from the right, our y value is approaching 4. That's going to put a point right there at 3, 4. Now, you'll notice I drew both of those as open dots. All right. The problem says absolutely nothing about the actual value of f of 3. So what that tells me, guys, is it could be 0 like that, or the actual value could be 4 like that, or it could be neither one of those. The function might even be undefined at 3, or maybe it's got a completely different y value like 6. But what is impossible, though, is for both of these dots to be filled in, because now this graph fails the vertical line test and it would not be a function. And since they have named it f of x, we know that it is a function, and it therefore has to pass the vertical line test. So again, let's not make things too complicated, guys. What I would probably do is say, all right, I'm going to go from this point right over here where we were at the point 1, 2, and then as we approach 3 from the left, it's going to come back down here to 0, so I'm just going to make it go like that. Now on the right, I really don't care at all what the function does. I'm going to make it just kind of shoot up almost like a parabola, and just for fun, I'm going to go ahead and fill in one of those dots. But to be very clear with everybody, there is not just one right answer to this problem, but what all of us need to have is a dot right here at the point 1, 2. It could be open or closed. All right, but the graph needs to lead to it both from the left and from the right. We have to be approaching 0 as x approaches 3 from the left. This dot can be either open or closed. And we have to be approaching 4 as x approaches 3 from the right. This dot can be either open or closed, but both of these two dots, this one and this one, they can't both be closed and shaded. So again, lots of different ways you could do this. That's how I did number 51.